Okay, the thing about revenue problems or Peachtree problems is there's always going to be one variable that's increasing and one variable that's decreasing, which is going to allow us to have a parabola that opens down, which means we're going to have a maximum value. My first problem is a revenue problem. The Sweet Drip Beverage Company sells a soda pop. I don't. This must have been some northern company, and it finds that it averages 18,000 cans per month when it sells the cans for 60 cents each. It also found out that every time they raise the price by 10 cents, that the sales are going to drop by an average of 500 cans. So I'm going to let X represent the number of increases in price. In terms of the number of increases in price, how many cans will be sold? Well, there were 18,000, but notice that every time I make an increase in price, I'm going to drop 500 per that increase. This is how many are sold. Now, each dime increase in price, and now we're asking what's the price charged? Well, it was 60 cents, but notice that every time I make an increase, I add 10 cents per increase. And so 60 plus 0.6 plus 0.10x is going to be the price that I'm charging, or the Sweet Drip Beverage Company is charging. Now, what is my revenue? My revenue is how many cans I sell times how much I sell them for. So my revenue with respect to x is going to be equal to 18,000 minus 500x times 0.6 plus 0.1x. Number of cans sold times the price. All right. In C, it says to find a graph, R of x, for the problem situation. I don't really even need a graph, but I'm going to go ahead and put this on my Inspire since they told us to. And so I graphed 18,000 minus 500x times 0.6 plus 0.1x. There again is my number of cans sold times the price. My independent variable is the number of increases. I looked at this x and I noticed 18,000 minus 500x. Well, if it was 20,000 minus 500x, if x were 40, that would have given me a 0. And so I just went out from 0 to 40. You can play with it. If you've got Desmos, you can use your fingers to spread it open and close it back to get it the way you want it to look. Okay. Then for the dependent variable, I noticed that if I didn't make any increases in price, I would have sold 18,000 cans at 60 cents, which is closing in on 10,000. It has to be more than that. And so I just raised it up to 30,000. It gave me a pretty good curve, and so I didn't mess with it. So my window's going from 0 to 40 on the x's and 0 to 30,000 on the y's. Doesn't have to be exact, but that's good enough. And now what I want to do is I want to find the maximum. So I'm going to figure out the maximum of my graph. I go to the left of the maximum, to the right of the maximum, and I did a fixed 2 because I wanted dollars and cents. In this case, it's a perfect dollar amount. The best thing I could do for my revenue is to make 15 increases in price. 15 increases in price. Whee! And if I did, that would give me $22,050 per month. 15 increases in price. So how much should they charge? Well, notice I'm making a dime increase in price. So if I made 15, that would be, here I'm going to put in 15. That's going to give me $1.50 plus the 60 cents. I'm going to end up having them charge $2.10 per can of soda. This must be an amusement park or something because I don't think I would pay that at a grocery store. But the amount that they should charge to get maximum revenue is $2.10. If I wanted to do that without wrapping, I could think about this as being in intercept form for a quadratic. What value of x would make this term be 0? I could do 18,000 minus 500x is equal to 0. 18,000 is equal to 500x. Cross off a couple zeros. 180 divided by 5 is 36. So I would have 1 0 at 36. My other one would come from here. 0.6 plus 0.1x is equal to 0. 6 plus x is equal to 0. Just multiply both sides by 10. And I get x is equal to -6. Okay. So I've got a 0 at 36, a 0 at -6. My axis of symmetry must be midway between 36 and -6. That would be the average of those two numbers. 36 plus -6 is 30. Half of 30 is 15. So I should make 15 increases in price. Didn't even need a graph to do that. 15 increases in price is going to give me a total of $2.10 per can. And then I could have plugged it into the formula if I needed to know what the maximum revenue is. The maximum revenue you could get per month is $22,050. All right. The second problem is a peach tree problem. Farmer Sakio has a peach orchard. He has 40 trees in the orchard. Each tree produces 1,000 peaches. He notices that every time he plants an additional tree, I guess it uses up resources, and the output drops by 10 peaches. If T is the number of trees that Sakio should add, what would the total peach production be? Well, that would be the number of trees times how many peaches there are per tree. Okay, so what is the number of trees? The number of trees, he started with 40, and he's adding 1 peach tree at a time. The number of trees is 40 plus T. How many peaches per tree? Well, he started with 1,000. And notice that he is dropping by 10 every time he plants a tree. So the number of peaches per tree is 1,000 minus 10T. And if I multiply those two together, that's going to tell me how many peaches he has. And so the number of peaches, based upon the number of trees planted, is going to be 40 plus T times 1,000 minus 10T. Once again, you could graph this, make a parabola that opens down, figure out the maximum based upon the graph. But I'm going to look at the zeros. Notice this factor, the value of T that would make this 0 is -40. This one, the value of T that would make it be 0 is 100. -40 plus 100 is 60. Half of 60 is 30. So how many trees should he plant? He should plant 30 more trees, give him a total of 70 trees. 30 times, let's see, 10 is going to be 300, so he would have an average of 700 trees, 700 peaches per tree. Almost every revenue problem, every peach tree problem you do is going to work the same way. Figure out the variable that's increasing, figure out the variable that's decreasing. You got it made.